Today we're going to cover section 3 of chapter 1. Today we're going to learn how to calculate and learn the definition of midpoint and distance. So the first thing we're going to do is define what a midpoint is. And a midpoint is just a point that divides the segment into two congruent segments. So for example, if M is the midpoint of JK, so here is JK, it's this segment right here. So if M is the midpoint, then that tells me that segment JM is going to be equal to segment KM or MK. And again, you could name it either way. And notice they both are labeled with a length of 3. Now, if they didn't give me how long each one of those segments were, then another statement I could make is just that JM is congruent to MK. So let's say, for example, they didn't give me the 3, but what they gave me were congruency marks. So whenever something is a midpoint of a segment, it's going to split that segment into two equal pieces. Now, just like I said last week, if I were to give you a picture like this, and let's say I put A, B, C here, a segment that looks just like that with no markings on it or no numbers, I can't assume that B is right in the middle. I would either need to have been given congruency marks to show that AB is the same length as BC, or they would have to have given me numbers. And maybe they told me that AB was 4 and then BC was 4. Then I could conclude that B is the midpoint because it's right in the middle. So the next definition is that of a segment bisector. And a segment bisector could be a point, it could be a ray, it could be a line, it could be a line segment, or it could be a plane. Anything that is going to intersect a segment at its midpoint. Now, the thing that is getting bisected, it can't be a line, because remember, a line goes forever and we couldn't find the middle. It can't be a plane either, or a ray. So generally what you're going to bisect, what we're going to see a lot of, is either a segment or an angle. And we haven't talked about angles yet. So right now, all we're talking about are segment bisectors, and these are things that are going to split our segment into two equal pieces, or in other words, two congruent pieces. So in this particular picture, line CD is the segment bisector of segment AB. So then that tells me that this piece over here, AM, is going to be equal to MB. Or you could also say that it's congruent. So when I have congruency marks like this, I'm going to use the congruent statement. If I had numbers, I would state that they're equal because I would know the exact measure. Now, let me draw another segment and show you a different way that we could bisect it. So let's say we have another segment here. And I'm going to still call it AB. But this time, my bisector could be a ray. So before, it was being bisected by, and I know I didn't really draw it to scale here, so let me shorten it up a little bit. Remember, your drawings are never drawn to scale. So when I first drew it, it sort of looked like it was uneven. But as soon as I put congruency marks there, then I can tell that AM and MB are the same because they have the same congruency mark. So my statement here could be that ray MC is a segment bisector of AB. So the segment that's getting split is AB. The thing that's splitting it is ray MC. So again, remember, a bisector could be a point, a ray, a line segment, or a plane. And point M here is the midpoint. What she just asked was, could I put, so like if this were my segment, A and B, as long as it's got the same little tick mark, whether I put it there or there, as soon as you see it in between 2 points, that'll tell you that this little segment will be the same as this. And it doesn't have to be right smack in the middle. So for example 1, this is looking, I guess, down on a skateboard. So this is a skateboard design, top of a skateboard. And they're telling us that VW bisects XY at point T. So here is my segment VW. And they're telling me that it bisects XY, which is here, at point T. So point T here is going to be that midpoint of XY. Now, if you zoom into the picture, you can see that they actually added congruency marks here. I sort of wrote on top of them. So that would be another clue if you're given a picture of something to tell if it was bisected by looking for those congruency marks. Now they gave me the length of XT, and they told me that this segment right here is 39.9 centimeters. Well, since that segment XY was bisected, then I know this one, and it has the same congruency mark, is also going to be 39.9 centimeters. So if it wants me to find the length of the whole thing, XY, all I need to do now is take 39.9, add it to itself, or I could have also multiplied it by 2. So I'll go ahead and add this up, and I get 79.8 centimeters. Same answer if I were to multiply it by 2. So the answer to the question would just be to find XY. Now, when you're doing the homework for this, even if it's simple calculations, I still want to see you show your work. Even if you're adding 2 plus 2, I need to see the work. Okay, we're not going to be using a calculator for the quiz. I know I told you needed to purchase that calculator, the TI-30 XIIS, but there's going to be some people who won't be ready to use that calculator on Wednesday. So more than likely for the first chapter, we won't use a calculator right away. We'll give everybody the opportunity to get it, and then maybe when we start chapter 2, we'll start using it. One thing that we do quite often in this honors course is we actually write proofs. This sort of separates us from the regular geometry course, whereas we hold you to a higher standard. We're trying to develop your critical thinking skills to get you ready for that wonderful AP Calculus class. So just to show you a little preview, this will not be on your quiz, of something that's going to be coming. So for example, if I were to take this word problem and turn it into a proof question, the way that it might be presented is whenever you're asked to write a proof, you're going to be given a given statement. So in this case, what they gave me was that VW bisects XY at point T, and that XT equaled 39.9. I'm also going to tell you that X or TY equals 39.9. I'm going to ask you to prove that XY equals 79.8. These are both centimeters. So this is how you'll be presented information for a proof. I'll give you a statement, whether it's a diagram or it'll be spelled out like this. And then I'm going to give you something to prove. So what you're going to do is you'll set up 2 columns. You'll have a statement column, and you're going to have a reasons column. The reasons are always going to be definitions, theorems, postulates, different things that you're learning and you're memorizing. The statements can involve, again, the same thing, but they're going to be more specific to your given information. So your first statement and your first reason, the reason is always given, and then you're going to restate what they have given you right here. So I'm going to put that VW bisects XY at point T. And I'm also going to state that XT, which equals TY, which equals 39.9. So since I was told that VW bisects XY at point T, I could use my segment addition postulate that I learned last week and show that XY is composed of adding XT plus TY. And that reason is your segment addition postulate. Now, because some of these reasons are going to get kind of long, this is why I like to come up with acronyms. So instead of having to write these 3 words, I'm just going to put the letters SAP. The next thing I need to do is substitute that given, and I'm going to replace both the TY and the XT with what it equals. So I'm going to show that XY is equal to 39.9 plus 39.9. And that reason is substitution. This reason will show up all the time in our proofs. The next thing I'm going to do is simplify or add the two 39.9s. So 79.8. In this reason, you can either say that you simplified, or the other reason would be add. And now, my last statement is always what they had asked me to prove. Now, this whole process of writing proofs takes a little bit of practice. For some of you, you're going to catch on right away. For other of you, you might not get it till January. It may take a while to get the hang of it, but we will slowly introduce this to you. I will not expect you to write an entire proof yourself like this. At the beginning, I start out by giving you part of the things, and then you'll fill things in. But again, this is not on the first quiz. It's just a little taste of what's to come. All right, so example 2. They're giving us that point M is the midpoint of VW. And it wants us to find the length of VM. So I know that when I have a midpoint, I know that that midpoint splits my segment into 2 congruent pieces. So because M is the midpoint, I know that segment VM is going to be equal to MW. And this is going to be the algebraic equation that I set up to solve. So I'm going to take my VM, and I know it's equal or congruent to my MW. Actually, I'll put it in as a congruence. So now what I'm going to do, and again, you could either show it as VM equals or VM is congruent. So this is the little wave. Or you could say that MW and VM are equal. So I'm going to go ahead and replace VM with the 4x minus 1 and the MW with the 3x plus 3. Now I need to find my value of x, and then I'm going to take what I get for the value of x and substitute it in for the expression for VM. So I'm going to go ahead and start my solving process. I need to get my variables on one side of the equal sign. So I'm going to subtract 3x from both sides. I'm left with 1x, or just x, and then the minus 1 equals 3. Next, I need to move my constant. So I'm going to add 1 to both sides, and I get x equals 4. Now, the question did not say find the value of x. It said find the length of VM. So now what I need to do is figure out the expression for VM. And remember, VM was the 4x minus 1. I'm now going to take my newly found value of x, and I'm going to substitute it in. So I'll do 4 times 4 minus 1. 4 times 4 is 16 minus 1. And the length of VM is 15. Now, just to show you how I can vary different versions within the class. So for example, let's say on Wednesday's quiz, I give everybody the same original question or the same diagram, but instead, one version I may ask for VM. Another version, I may say, give me the length of MW. Well, if you recognize that this was bisected, you know it's going to be 15. But if you had to show the work where you take its expression, plug in the 4, multiply and add, notice you also get 15 for MW. But what if I said, instead, find VW? Remember, VW was the whole thing, so you would have had to have done 15 plus 15, and it's 30. So just by changing one little letter, I can actually change the question, but give the exact same picture. Sometimes I give a picture like this, and instead of 4x minus 1, maybe on a different version, I'll have 4x plus 1. So I make slightly little different changes to the problem when it actually looks the same. The next slide has the midpoint formula. You will be required to memorize this formula for Wednesday. This is a formula that you will not be given on a PSAT or an SAT, so this is why I want you to memorize it. Now, it looks like it's a bunch of stuff on here, but really all you're going to be given are 2 ordered pairs. You're going to add the x from each ordered pair, divide by 2, and then add the 2 y's and divide by 2. These little 1s and 2s that are here, these are just little labels or subscripts. So my point A here in the picture is just my ordered pair number 1. And then I'm going to say point B here is ordered pair number 2. That's what the little 1s and 2s represent. So all you're going to do is take the x from each one, add them both together, and then divide by 2, and that will give you the x of your midpoint. And then you'll do the same thing for the y's. So our answer is always going to be an ordered pair. Now, when I give you the question on the quiz, I'm not going to give you a graph. I'm just going to give you a sentence and tell you what the 2 ordered pairs are, and I'm going to ask you to calculate the midpoint. Okay, so for the first one, I'm going to go ahead and say, I want point R here to be my ordered pair number 1. So this is going to be my x1, y1. It doesn't matter if I would have said R is ordered pair number 2. And then my S will be my x2, y2. So now what I'm going to do, they want me to find the midpoint. Now in the quiz, I'm not giving you this. Because honestly, I know you can just look at it and figure out what the ordered pair is for M. All I'm going to give you on the quiz is a sentence like this. So let's go ahead and write down the formula just so we can make it permanent in our brain. Sometimes when you write things multiple times, it helps. So your midpoint formula is going to be adding x1 plus x2, divide by 2, and then y1 plus y2, divide by 2. This is going to give you the x of your midpoint. This one's going to give you the y of the midpoint. And again, it's going to be an ordered pair. So let's go ahead and replace the numbers into our formula. You need to be very careful with negative numbers. You're following your rules for integers. So for example, this is going to be my x1 is the number 1. So I'm going to take the number 1 and I'm going to put it here. Then I'm going to go back and I'm going to get my x2. which is the first number in the second order pair. And then that's what I'm going to put right there. So that's what I'm filling in. So then I get 4, and then divide by 2. This is going to give me 5 over 2, which is the x of my midpoint. So far, I've got the first part of my order pair. Now I have to go back and find the y of the midpoint. So I'm going to take my y1, which is -3. I'm going to put it right here. So -3 plus, and then I'm going to go and get the y2, which is here, which is 2, add it to the y1, and divide by 2. -3 plus 2 is -1, and then divide by 2. Now, on the quiz, I'm okay with you leaving that x of your midpoint as an improper fraction. If you were to actually have to graph this, then I would probably want you to either make it a mixed number, or you could have also made it a decimal. So on the quiz, I would accept any one of these 3 answers. Now, when we start the online homework, they'll be specific, and they're going to either say, enter your answer as a fraction, or enter your answer as a decimal. So just read the instructions when we start the online homework. But for right now, your homework for tonight and for the quiz, I'm okay with you leaving it either way. Next one, be very careful and read the question. This time, they're giving us the midpoint already calculated, and they're giving us one of the endpoints. So I'm going to go ahead and label this so it's easier for me. This is going to be the x of my midpoint. The 1 is the y of my midpoint. And then j, this could be my x1, and then the 4 could be my y1. I'm trying to find endpoint k, and that's going to be my x2, y2, my second order pair. So let me go ahead and write down the formula, and you're going to see how you're going to replace it. So we're sort of working backwards of the formula. So remember, to get the x of the midpoint, we take x1 plus x2, divide by 2, and that gives us the x of the midpoint. For the y, you add the 2 y's, divide by 2, and it'll give you the y of the midpoint. So I'm going to replace what they've given me. So I'm going to take this xm, the x of my midpoint, and I'm going to put it right here. So I put the 2 right here. And then I'm also going to grab the x1 from the order pair, which was 1. It's going to go right here. I don't know the x of the other endpoint, and then it's divided by 2. Here's where your algebra skills come into play. I need to first, when I'm solving this, get rid of the 2 in the denominator. So I'm going to multiply both sides by 2. And now I'm left with 1 plus x sub 2 equals 4. Subtract 1. And the x of my endpoint, or point k, is 3. So far, for point k, the other endpoint, I've got the first part of the order pair. Now I got to get the y. So now I'm going to take, again, the y of my midpoint, this 1, and I'm putting it right here. And then I'm going to go ahead and grab the y of my point j, which is right here. Switch colors. 4 for that one. So now I have 4, and then plus y sub 2, divide by 2. So just like before, we need to multiply both sides by 2 to get rid of the fraction. And now I'm left with 4 plus y sub 2 equals 2. Subtract 4 from both sides. Y sub 2 equals negative 2. So now my endpoint K is the ordered pair, positive 3, negative 2. So on the quiz, be able to calculate a midpoint given both endpoints, and also be able to find an endpoint given one of the endpoints and the midpoint. Next, we're going to learn the distance formula. This is the distance formula. You need to memorize it. Now, for those of you who maybe have learned the Pythagorean theorem, you can also use Pythagorean theorem to find a length of a diagonal, and in this case, it would be the hypotenuse. We don't officially learn Pythagorean theorem until chapter 9. So for you guys, you'll probably be better off memorizing the distance formula, because I'm going to give you 2 coordinates, but I'm not going to provide a coordinate plane where you could graph them, because then you'd have to find the lengths of the legs yourself. So you're better off taking the 2 order pairs that they give you. Order pair number 1, again, these little ones are subscripts or labels, and then order pair number 2, and then replacing the values into the formula. So you're going to subtract the x's and square them, subtract the y's and square them, then add those 2 differences that you've squared, and then square root it. We will not be using a calculator, so you will be leaving your answers in simplest radical form. And I'm going to show you what I mean by that coming up. So let's try 2 examples. This, when we did these other ones, when we found the distance of 2 segments, most of the segments that I had you graph were either horizontal or vertical lines. Whenever you have something that's horizontal or vertical and it's on a coordinate plane, you can count the little boxes. However, when it's diagonal, like this line here, you can't count the boxes. You have to use the formula. So let's try it. For the first one, now back. So again, this is how I will present the question on the quiz. I am going to give you 2 ordered pairs, and all you're going to do is take those 2 points and plug them into the formula. So just to recap, the formula is you take your x's, you are going to subtract them. So x2 minus x1 squared plus y2 minus y1 squared, and it's all under a radical. It's under a square root symbol. I'm going to go ahead and say this is my order pair number 1. This will be order pair number 2. It doesn't really matter. You can choose. So I'm going to go ahead and subtract my x's. So I'm going to do 7 minus 13. And that gets squared. Then I'm going to take the y's. 10 minus 2. And it's squared, but then this whole thing's under the square root. I have to follow order of operations. So I have to subtract first, then I square it, and then I'm going to add and square root. So 36 plus 64. I'll now add that, and then I square root. You should have already memorized the first 12 perfect squares in 3rd grade when you learned your times tables, because you should know 1 times 1, 2 times 2, 3 times 3, all the way up to 12 times 12. So the square root of 100, you're looking for what number times itself will give you 100, and that's 10. If it were 144 under the square root symbol, that answer would be 12. When I used to teach Algebra 1, I would tell my class memorize up to 20, because those are the ones that you're going to see quite often. Now, if the number that you get after you add is not a perfect square, we're going to leave it in simplest radical form. And I'm going to show you how we break it down. We do a factor tree. But let's go ahead and get first of all, what's under the radical. So again, I'm going to label this as x1, y1, x2, y2. And now I'm going to plug it into the formula. So I'm going to take my x's and subtract them and get my y's. So I'm just going to do 4 minus 2 squared, negative 1 minus 3 squared, all under the radical, 2 squared, negative 4 squared, square them, add them, and now 20 is not a perfect square. It's a number that's going to be in between the two perfect squares of 16 and 25. However, I'm not going to expect you to estimate it to a decimal. What I want you to do is a factor tree. So I would take 20 and I'm going to break it down till it's prime. Now it doesn't matter if I start with 2 times 10 or 4 times 5. I'm going to get the same answer either way. So I'm going to break it down. Now if you recognize 4 is a perfect square, you could square root it. But if you don't, break it down till it's prime, and then you look for a pair. I got a pair of 2's. That's a perfect square. It comes out. The 5 has no pair. He stays underneath. So in simplest radical form, this answer is 2 square root 5. And this is what I will expect to see on the quiz. Now, I highly recommend you show all your work when you're taking the quiz. Show how you plugged it into the formula. Show how you did the subtraction and squared. Because let's say you plugged it into the formula correctly, but then you made a careless mistake in subtracting or adding. You can get some points by showing work. So it's always very important you show your work. Now, let me just show you a couple other examples of breaking down radicals if you're not familiar with this. So I know this was the last slide, but let me add a page. Let's say we want to break down the square root of 48. Now, there's lots of ways to multiply to get a 48. 2 times 24, 3 times 16, 4 times 12. I'm going to start with 6 times 8. It doesn't matter because I'm going to keep going till I'm prime. So I multiply. This will be a 2 times 6, then a 2 times 4, and then this one still can break down. I keep breaking it and keep bringing everything down until I have all prime numbers. Now that I have all prime, I look for pairs. I got a pair of 2's here. I got another pair of 2's. Even though they're not side by side, they still make a pair. It comes out. And this poor 3 doesn't have anybody to pair up with, so he stays underneath. Anything that comes out gets multiplied together, and your final answer is 4 square root 3. Now, for those of you who are really good, let's say you said, you know what? I know that 16 times 3 is 48. And then if you recognize 16 to be a perfect square, square root it, and then just leave the 3. You'll get really good at this because we will be leaving our answers exact. Even when we get the calculator does not do this for you. You will still always have to do it by hand. So practice breaking down radicals. Show your work. If you're stuck on these simplifying radicals, ask me to do a few more examples tomorrow. One more example. Let's say I wanted to break down the square root of 75. I could do 25 times 3. Breaks down to 5 and 5. Pair of 5's. 5 comes out. Square root 3. Now, if you would have done 75 as 15 times 5, you can do it that way as well. Just remember, you're going to keep breaking it down till it's prime and look for pairs. So 5 square root 3.